oxygen gas. So oxygen gas, 2 times 6, that's 12 electrons. Oxygen, oxygen. Fill this one up. There's 8. Then I do my central. Notice it didn't matter which one. Central. Okay. 2, 4, there's 10. I need another one. There's 12. This one has 8. This one has 6. I take these out. Make a double bond. It's got a double bond. That easy. This stuff is not meant to be hard. Oh, man. So let's make it hard. Let's make life more difficult then. Let's make it more difficult. You're going to say, no, Dr. J, don't make it difficult. So let's do no. NO here. All right. So nitrogen, 1 times 5 plus 1 times our oxygen. So I've got 11 electrons. We'll come back to that. Oh, man. No charge on this, right? So here we go. And connected to O. Oxygen is closer to fluorine. That is my outside atom. This is my central atom. So let's start on the outside. There's 2, 4, 6, 8 U's. I've got 3 left. So I add a pair over here. All right, I got 1 left. Well, I can't add a pair, but I can add a dot. So let's add that dot. Now, step 5. We've used all our electrons, right? We need to make this happen. Now, I can move this lone pair over here. That ain't going to really help. So I need to take this lone pair and try and move it in here. So this has 2, 4, 5. So when I put this double bond, oxygen still has 8. Nitrogen has 2, 4, 6, 7. Ooh. Now, you might say, why don't we make a triple bond? Since it wasn't happy, we'll make a triple bond. But now it has 9. And that's no good. This is no good. Because nitrogen has a 2s2 and a 2p6, and it can only hold 8. So they can't hold 9. So this is no good. And this is the closest we can get. Is this nitrogen happy? No, not at all. Man, this place where we have 1 dot by itself is a free radical. A free radical. Man, those things are crazy reactive. If we could lose this dot, I could make this triple bond and have 8. If I gained another electron, I'd have a lone pair here and a lone pair here. This would have 8. Nitrogen would be happy. If I connected this to something else, even to another NO, and made a covalent bond here, then nitrogen would have 8. So this will react with whatever it hits. It will gain an electron. It'll lose an electron. It'll share that electron. That free radical is going to do all kinds of stuff. Really bad in our body. Man, you probably heard of it. When you watch your TV and they try to sell you and they say, hey, you should buy this anti-aging cream. It stops free radicals. Man, that's what they're talking about. So how do we know we were in trouble on that one? We knew we were in trouble. And I noticed it as soon as I saw that we had an odd number of electrons. And so that is our first exception to the octet rule. When we get an odd number of electrons, we're just out of luck. So my advice is when you get an odd number of electrons, first thing you do is double check your math. Maybe you missed a charge. All right. Something's wrong. But you're more likely to see it on a test than you are to see it in life. But they do happen. And it can cause all kinds of havoc. All right. The second one is we're going to worry about is when we deal with stuff like, let's do boron. Let's do BH3. And so this one needs to have 6 electrons. 1 times 3 plus 3 times 1. And it looks like this. And you might say, hey, that boron is not happy. But it turns out it is. Boron can hold 8, but it really only wants 6. And so we use boron for a lot of cleaning things because it likes to have 6, prefers to have 6, but it'll hold 8, which means if I put it with water, it can grab onto water, and then it can come back and let go of that since it's not really easily bound. It helps to grab grease. We'll stick onto it a lot. So this is our second exception to the octet rule, and we call this an incomplete octet when we're not getting to 8. All right. So boron and aluminum, they like 6. So aluminum, we said, is usually going to be a +3, but if we make it do covalent, it only wants to have 6. It could be worse. Beryllium likes 4. So beryllium, we say, likes to be a +2, or is always going to be a +2. Treat it as a +2, but if we force it to be covalent, we decide it's going to be covalent, it's really going to be wonky. Those are memorization. Just got to memorize. Those are the exceptions. Okay? So we have those, we have an incomplete octet. Ready? Get your Advil out. Here we go. This third one. Oh, let's do this one. PF5. 1 times 5 plus 5 times 7. That would be 40 electrons. Now the skeleton is the hard part. The skeleton on this one is the hard part. So you say, Dr. I'm not sure how I want to draw this. Well, here's how we're going to draw it. I'm going to put a fluorine and a fluorine and a fluorine, a fluorine, and a fluorine. Oh, look. I've got 5 fluorines. If I fill up each one with 8, that would be 40. So I'm going to go ahead and dot. I'm imagining my boxes. 4 sides to each box. These boxes. Don't do this. Don't do that. This has already got these. Don't be putting 2 there. They go over here. All right. And don't do that so that you know that this is 2. That's just going to confuse you. All right. So, don't do that. You'll notice when I do this, I'm imagining a box around my fluorine, and I'm keeping one side's already full with this. So, my fluorine has, each fluorine has 8. They're happy. There's none left to go in the phosphorus. The phosphorus has 10. It's happy. What? Oh, yeah. Yeah, you're right. When I did nitrogen, I said I can't put 9. We tried to put an extra one. I said there's no place to put it because it only has the 2 S and the 2 P's. Well, phosphorus is sneaky, though. It has the 3S. It has the 3 P's. And sitting out there empty, it has the 3 D's. So this is called an expanded octet. Now, I always like to say the third period and down, or more than, so we're going to, it has to have the d orbitals. And so we're going to go the third third period and down. All right. So not period 1 and 2. It has to have empty d orbitals. And how do we know it's going to fill? It'll fill right. You're going to have more on these. So phosphorus and sulfur, they like to do these kind of things. But it has to be on the third period and down. So in other words, what do I mean by that? When I look over here, the third period and down. So these are the d orbitals. The 3Ds are down here. We haven't filled them yet. So all this phosphorus is doing is throwing some in. So nitrogen couldn't do it because it was only on the second period, but phosphorus and sulfur, they love doing this kind of stuff. All right, so here we go. We got incomplete octets. We got beryllium like 4 electrons, and then outer layer, boron and aluminum like 6 valence electrons. If we have an odd number, we'll end up with a free radical. And if it's on the third period and down, if I go from here down, then I have the possibility of expanding my octet.